This is the take-home practice quiz 3.1 to 3.4 help video. They get you a little push in the right direction for each of these problems. For this problem, it tells you to just solve for x, but one of the rules of thumb is to simply find everything possible. So things you want to watch out for are vertical angles. You want to watch out for linear pairs that add up to 180. Watch out for triangles add up to 180. Things like that. So just find absolutely everything possible, and then you'll find the single angle that you need. For example, we start with 101 over here. That's 180. And of course, that's going to be 79. And we get 67 here. And then, of course, that's 180. So that's 113 here. $149, take away 150 gets you 31. And then if this is 31, it's a bow tie or vertical angle, which gives you x is 31. So basic rule of thumb is to find everything possible using what you know about angles. Triangles add up to 180, vertical angles, linear pairs. Says in the figure below, L is parallel to M. L is parallel to M. So trace. Whenever you have parallel lines, you should be watching out for armpits of the Z. So if this is 60, that's 60. Again, it asks you for this particular angle. Never just find or hunt for the single angle that you're being asked for. Instead, simply find everything. For example, I could easily find that angle by going 65 and 60. 125, take away from 180. I get 55. I ask myself, what can I do? I have a linear pair here. So 55 away from 180, of course, is 125. Number 3 is going to be talking about isosceles and equilateral triangles. Taking a look here, it says find the measure of angle M, which would be this single angle. But once again, don't ever focus just on what you're being told to find. Always ask yourself, what do you know about the diagram in general? And what I know in general is I have 3 equal sides. If I have 3 equal sides, by implication, I have 3 equal angles. So I simply do 180 divided by 3, and I find each of the angles, of course, are 60, which gives me the singular angle I'm being asked to find. What do we notice here is that we're being asked to find the measure of angle Q, the angle. Once again, never singularly focus on what you're being asked to find. Ask yourself what's true because of the diagram. Because of the diagram, I have 2 equal sides. If I have 2 equal sides, I have 2 equal congruent angles. Therefore, to find the measure of both those angles, I'm going to go 180 minus 30. I get 150, and I'm going to divide by 2. And I find that each of them are going to be 75 degrees. Number 4. Again, it tells you to find a singular angle, which would be x. Never focus on that singular angle you're looking for. Again, look at what does the diagram tell us. And in this diagram, I am told I have 2 congruent sides. 2 congruent sides, 2 congruent angles. So if that's 23, this is 23. which means together they are 46. Take that away from 180. And I get 134. Watch out for linear pairs. 180 minus 134 is going to be 46. I take a look here. Again, what does the diagram tell me? It tells me that these two angles have to add up to 90 degrees. So 90 minus 46. And you get 44 degrees. We are told that right here, HIJ is isosceles, and we have two equal sides. If we have two equal sides, we have two equal angles. So that means angle H and angle J are congruent. You're given variables for H and I. Let's do a thing before algebra. In this diagram, the two red angles plus the blue angle adds up to 180. Let's see what we can do here. Our red angle, one of them, they are congruent, is going to be 3x plus 24. I ask myself, I have two equal sides, I have two equal angles, which means this angle must also be 3x plus 24. Plus my one angle here, which is 5x plus 44. Collect like terms. That's 6x plus 5x, that's 11x. 24 plus 24 is 48. That's 44. I have 11x equals 88. And x equals 8. Never, ever stop at the variable. Alex is not asking for the variable. It's asking for the measure of each angle. So you need to go back, and this is a good way to check your work. 3 times 8 is 24. Plus 24, that means this has to be 48 degrees. This has to be 48 degrees. And 5 times 8 is 40, plus 44 would make that 84. You can come here in the margin. We're going to go 84 plus 48 plus 48. We're going to check our work. That's 16, 4, that's 20. That's 10. That's 8, so it's 18. Boom. Now you know you're correct. Again, you're being asked to find a particular angle, but do not focus on the angle. Focus on what you have. If you watch the markings, 2 equal sides, 2 equal angles. So if that's 35, that's 35. Together, that's 70. Take it away from 180. That makes this 110. 180. That makes this 70. Hatch marks again. 2 equal sides, 2 equal angles. That's 70. This is 70. Together, that's 140. Take it away from 180. And we get the measure of angle X is 40 degrees. So, a couple things you want to watch out for. is if you have two equal sides, you have two equal angles. Also watch out for linear pairs that add up to 180. Those are easily overlooked. You determine whether a triangle is a right triangle. So let's just recap very quickly what is meant by a right triangle. A right triangle is a triangle with a right angle. Now, how can you prove that two sides are perpendicular on when you're given a coordinate plane? Now, there's two ways to do this. You can get out graph paper and graph each and every one of these, or we're going to use the slope equation, because if we find a set of slopes and slope times slope equals -1, then I know that there must be a right angle, and if there has to be, the lines must be perpendicular, therefore it has to be a right angle. So you're going to have to find the slope of all three combinations. So for example, I'm going to do this verbally. Y minus y over x minus x. So I'm going to go t to r. Y minus y. That's 6 minus -9. It's going to be 15. 10 minus 7. That's 3. I go this way. 9 minus -9 minus 0. It's -9. 7 minus 1. That's 6. And then this one, I'm going to go this way. 6 minus 0, that's 6. 10 minus 1, that's 9. Now I take a look. Do any of these multiply to -1? And if you look very carefully, these are opposite reciprocals of each other, which means in this that these two segments, the TR and RI, must therefore be perpendicular, because -9 over 6 times 6 over 9 is going to be -1. So this is a right triangle. So you have to find the slope of all three combos, and if you have a single instance of slope times slope equals -1, then it is perpendicular, therefore it is a right triangle. There is one exception to this. You must watch out for that. If, on a coordinate grid, something's completely horizontal, that's 0 slope. Something completely vertical, that's undefined. That is still a right angle. So just watch out for that. You must determine whether, with the given vertices, whether it's scaling, isosceles, or equilateral. This is a distance equation, so I'm going to do the first one. Okay, you're going to do distance equation 3 times. So it's best if you set up templates for all 3 times. It goes faster if you set up templates first. Okay, step number 1, I'm going to do A. So I'm going to go 1 minus 2, 0 minus -5. 1 minus 2 is -1 squared, that's 1. That's 5 squared, that's 25, so that's going to be root 26. this way. Again, I'm going to do the x's first. That's 2 minus -3. 5 minus -5. Double negative makes a positive. That's 5 squared. That's 25. That double negative makes a positive. That's going to be 10 squared. That's 100. So I have square root of 125. Last one. Is 1 minus -3 and 0 minus -5. That's going to end up being 4 squared. That's 16 and 25, which makes this square root of 41. Now none of the sides are equal, therefore you have yourself a scaling triangle. Classify each of these items below. So let's quickly go over the definitions. There's 4 you should be familiar with. A median goes from vertex to a midpoint. That's a median. Vertex to a right angle. That's an altitude. If I were to do going through at a right angle, bisecting a side, that's a perpendicular bisector. And if I were to simply bisect an angle, that is an angle bisector. So for this one right here, it's going through the middle, so I know it's a bisector, and it's a right angle, so it is a perpendicular bisector. This one, it's going from a vertex to a midpoint. Vertex to a midpoint, that is a median. This one is vertex to a right angle. That is an altitude. We are told that ST and U are all midpoints, which means we have a bunch of mid-segments here. So right here it says PR is 96. If PR is 96, ST, which is its mid-segment, will be half of that. So that's going to be 48. It says PQ is 100. If that's the case, TU is half, which is 50. If SU is 14, the side it faces is double, is 28. Because mid-segment is half of the side. So you take a look at what you have here, and you already have all your answers. QR is 28. S to T is 48. Q to T, take a close look. It's asking for Q to T. Once again, if that's a midpoint, the whole thing's 28. Q to T must therefore be 14. Consider the triangle below. You're given the vertices. K is the midpoint of TU. So we want to find the midpoint here. It's very important you do this accurately. Of TU, we're going to find the midpoint going that way. And then we're going to find the midpoint L of UV going this way. So step 1, I'm going to find the midpoint by add the x's, divide by 2, add the y's, divide by 2. This side, add the x's, divide by 2, add the y's, divide by 2. Here, -6 and 2, 1 and -5. This is -4 divided by 2, -4 divided by 2. My midpoint here is going to be -2, -2, which if you graph it, what's really nice about these is they actually will be drawn to scale. So there's my K, which is -2, -2. Now I'm going to find my L, add the x's, 4 and 2, add the y's, 3 and -5. That's going to be 6 divided by 2, -2 divided by 2. And my L has to be at 3, -1. So 3, -1, right there is my L. So now I have the mid-segment KL by finding the midpoints. Now I'm going to find the slope of KL and the slope of TV. So KL slope and TV slope, y minus y over x minus x. KL is going to go like this, y minus y, that's -2 minus -1, x minus x, -2 minus 3, and then TV, 1 minus 3, -6 minus 4, and then you reduce. This becomes +1/5. And this also will become +1/5. So the slopes are exactly the same. If you're wondering where I got +1/5 then, let me just show you the math a little bit more extensively. This is -1 over -5. This is -2 over -10. Both of these reduce to +1 over 5. So now I have proven mathematically, 1, that I have a midsegment. 2, I have proven that they are parallel to each other. Next, we're going to find the length of KL and the length of TV. So in the margin, KL, TV, I'm going to use the templates. This is going to be -2 and 3, -2 and -1. And T to V. -6 and 4, 1 and 3. Taking a look here. You're going to need to reduce these. That's negative 2 minus 3, that's negative 5 squared. That's going to be 25 plus negative 6, that's negative 1. It's 1 squared, so that is going to be root 26. Taking a look here, this is going to be 100 plus, that's going to be negative 2 squared, that's 4, so it is root 104. Now, that doesn't look like one's double of the other. That's why it's very important you factor. So we're going to factor here. We have 2 and 52, and we have another 2 and a 26. So this actually becomes 2 root 26. Now it's very easy to see one is literally double of the other. So you need to make sure you simplify and factor. So we have here root 26 and 2 root 26. So the relationship between the mid-segment KL and TV is an example. The segment that joins the midpoints of the two triangles is, in other words, the mid-segment is half of the third side. Whoops, let's get that in order. We started with parallel, so it'd be parallel. Segment that joins the segments of the two triangle is parallel to the third side. And then the second one, segment that joins the two triangles, is half the length of the third side.